If the Earth were a globe with a curvature drop roughly equal to 8 inches per mile squared, and the surface of the Earth and its atmosphere allegedly rotated at approximately 1,000 miles per hour at the equator, as claimed by the globe model, you'd assume those claims would be vital to NASA and the military for modeling and building aircraft. Instead, you'll see through declassified documents that government agencies and their contractors repeatedly assumed a flat and stationary Earth. For example, this NASA document assumes a flat, non-rotating Earth. Georgia Institute of Technology, on behalf of NASA, the model used is a flat, non-rotating Earth. Technical memo from the NASA Langley Research Center, flat, non-rotating Earth. NASA Technical Memorandum, flat, non-rotating Earth. NASA publication on the derivation and definition of a linear aircraft model, flat, non-rotating Earth, and flat, non-rotating Earth. NASA contractor, flat, non-rotating Earth, and flat Earth assumptions. NASA Ames Research Center, non-rotating flat Earth. Army Research Laboratory, flat Earth. Army Research Laboratory, propagation of electromagnetic fields over flat Earth. Army Research Laboratory, a flat Earth approximation provides the best estimate. NASA Technical Paper, stationary atmosphere over a flat, non-rotating Earth. NASA Technical Memo, a non-rotating Earth. MIT Department of Aeronautics and Astronautics, flat Earth, flat Earth. NASA Memo, flat, non-rotating Earth. NASA Contractor Report, assumption based on the Earth is flat and non-rotating. NASA Technical Memo, flat, non-rotating Earth. NASA Technical Paper, stationary atmosphere and flat, non-rotating Earth assumptions. NASA Technical Note, flat, non-rotating Earth. NASA Langley Research Center, flat, non-rotating Earth. Army Research Laboratory, these equations assume a flat Earth. Even the Soviets made their assumptions based on a flat Earth. If the Earth were a ball and rotated at 1,000 miles per hour, you obviously would not see the repeated engineering assumptions that the Earth is flat and stationary.
One flight that should be a simple 11-hour shot across the Indian Ocean is from Johannesburg, South Africa to Perth, Australia. However, this flight takes a detour north, stopping in either Dubai, Hong Kong, or Malaysia to refuel, for a total flight time averaging over 18 hours. This ridiculously wayward detour is frustrating to say the least, but on the flat Earth map starts to make sense. Another quick and easy flight, you would think, is from Johannesburg to Santiago, Chile. While an easy 12-hour flight below the Tropic of Capricorn is to be expected, instead, every flight crosses the equator to refuel in Senegal, all the way near the Tropic of Cancer, for a total flight time of 19 hours. Though it doesn't make sense on the globe, as you can see, it fits perfectly on the flat Earth map. A third flight from Johannesburg is to São Paulo, Brazil, which should be a direct 10-hour flight across the 25th degree south latitude. But instead, every flight crosses into the north to stop in London to refuel, making the total flight time 24 hours. From Santiago, Chile to Sydney, Australia, a straight 15-hour flight across the South Pacific is expected. Despite refueling options in either New Zealand or any island in the South Pacific, the flight stops all the way at Los Angeles to refuel before continuing south to its destination. As already stated, these detours make no sense on the globe, but are explained and work perfectly well on the flat Earth map, having the North Pole at the center.
So here's some examples of the local sun and a flat landscape. You see the hot spots, the local hot spots? My opponents attribute that to glare off of water. So I used examples here with multiple bodies of water. So even if it is glare off of the water, it's localized. So in the heliocentric model, the sun's 93 million miles away. Look at that, it certainly doesn't appear that way. And furthermore, look off in the distance. Forget the debate with the lens and the rectilinear and the wide angle lens. Look straight out ahead. There's supposed to be 50 miles of drop at that altitude. It's approximately 20 miles up. And according to the Earth curve math, there's supposed to be about 50 miles of drop straight ahead. If you look out straight ahead, it's flat as a pancake. The horizon's flat, and there's another example of a local sun. You see the hot spot. So I've gone to suncalc.org. This keeps track of where the sun is. Okay, let's check equinoxes. Let's see what model fits. Okay, so the vernal or spring equinox is said to happen on the 21st or 22nd of September. Okay, so here is September 12th. So you have 7:05 a.m. sunrise and 19:30 sunset. So that's 12 hours and 25 minutes. So that doesn't work, but we're not quite to the equinox. So let's take a look. Let's go to the 21st of September. Okay? Now we got 7:09 to 19:19. So that's 10 minutes off. Let's keep looking. Let's go to the 23rd of September. A little closer. 7:10 to 19:16. So that's 6 minutes off. Okay, let's keep looking. How about the 26th? How about the 26th? Sunrise, 7:12 to 19:13. That's within 1 minute. And now, if you look at the sun, okay, you see the sun right here? It's setting. Okay, that's almost a perfect equinox, off by 1 minute. So sure, it's rising in dead east and setting due west. It's still spinning its circle, which is exactly what we would expect on a flat Earth, is it not?